Around the world, communities are discovering that per- and polyfluoroalkyl substances, or PFAS, are commonly found in the environment. In fact, according to the Agency for Toxic Substances and Disease Registry, most people in the United States have been exposed to PFAS. Similar scenarios are expected in other countries too. So what are PFAS, previously referred to as PFCs, and why should we care about them? PFAS are man-made chemicals. What makes these chemicals so attractive is their ability to repel water, oil, stains, grease, and heat. Because of their properties, they can be found in a wide range of consumer products, including non-stick cookware, stain-resistant fabrics such as some carpets and clothing, food packaging, and firefighting foams. However, scientific studies have linked exposure to PFAS to various adverse health effects, including increased risk of cancer and infertility, abnormal development in children, and disruption of hormonal and immune systems. There are several ways people can be exposed to PFAS, including ingesting contaminated food or water, breathing in contaminated air, or working in facilities that manufacture PFAS or materials that contain them. And PFAS are very persistent, meaning they can accumulate and remain in the human body and the environment for long periods of time. With concerns rising quickly about the risks associated to PFAS exposure, it is important to ensure proper monitoring of these chemicals in the environment. But since PFAS are a complex group of chemicals, it can be difficult and time-consuming to identify and quantify each of them. Scientists are turning to LC-MS technology to quantify various PFAS in water, wastewater, biosolids, soil, and sediments. To help laboratories and other stakeholders monitor PFAS in drinking and environmental waters, organizations like the Environmental Protection Agency, or EPA, the U.S. Department of Defense, or DoD, and ASTM International have established LC-MS methods for measuring PFAS. Other organizations are also working towards this effort. Recently, EPA updated its Method 537, originally published in 2009, to include some of the emerging PFAS, like Gen-X, which was introduced in the U.S. market as a replacement for PFOA. The updated method, EPA 537.1, can be used to analyze PFAS in drinking water using LC-MS. ASTM International published methods D7968 and D7979, which are used to analyze selected PFAS in multiple types of samples: water, sludge, wastewater, effluent, and soils. In these methods, samples are pre-treated differently, but all of them use LC-MS for quantifying PFAS. The DoD's methods for analyzing PFAS in environmental samples are similar to those developed by EPA and ASTM. However, laboratories using this method must comply with the requirements outlined in the DoD's Quality Systems Manual. This agency is also focused on studying the environmental impacts of aqueous film-forming foams, also referred to as AFFFs, a very complex group of chemicals under the PFAS family. The EPA, ASTM, and DoD are continuing to develop and publish new standardized methods to better understand the occurrence of PFAS in the environment. To help support advancements in PFAS research and testing, Shimadzu collaborates with these organizations and has vetted some of their standardized methods using Shimadzu LC-MS instruments. Incorporating proprietary ultra-fast technologies and patented ion-focusing technology, Shimadzu's LC-MS systems enable outstanding throughput and excellent data quality for the analysis of PFAS. To learn more about solutions for PFAS analysis, contact Shimadzu today.
Excellence in science. Shimadzu.